In December of 1996, Lockheed Martin embarked on a mission to redesign the venerable Atlas booster. The objectives: eliminate parts to improve reliability, reduce the number of engines and staging events, and most importantly, prove that Russian and American technology could be joined together in this new breed of launch vehicle. The result? Atlas III, the most operable and producible Atlas ever built. Over nearly 4 years, engineers and technicians worked to design and build what all knew would be the most powerful Atlas ever. They stretched the Atlas stage 10 feet to accommodate the additional liquid oxygen required for the RD-180 engine. Modifications were made to the thrust structure that houses the Russian-made RD-180, considered to be the finest in liquid rocket engine technology in the world. The inner stage structure was modified to accommodate the new single-engine Centaur. When all was said and done, this incredible team had eliminated over 15,000 parts, reduced the number of engines from 8 to 2, and eliminated 3 of the 4 staging events required by the Atlas IIAS. And on May 24, 2000, at 7:10 p.m., the Atlas III made history as the 5th new generation Atlas to perform flawlessly on its maiden flight.
10, 9, 8, 7, 6, 5, 4, 3, 2, and the RD-180 engine roars to life and liftoff for the maiden flight of the Lockheed Martin Atlas III rocket with the W4 spacecraft on board for Eutelsat of Paris, France. With this Atlas flight underway, let's listen to Mr. Rob Gannon providing ascent data from the telemetry lab here at Mission Research Center.
We have Atlas PU to closed loop control. Engine operating parameters continue to look normal. And we are throttling up. Vehicle rates look nice and smooth. Throttle up is complete, everything looks good. And we're now passing through the region of maximum dynamic pressure. And rates are smoothing out as we're passing through transonics. And everything continues to look normal on the engine, staying steady at 87% thrust. And we're continuing to show the throttle segment, everything looking good. We've throttled down in preparation for PICO. We have booster engine cutoff. Everything looks good there. We have stopped boost phase chill down right on time. We have stage separation. We have full pre-start.
And we've had a nominal PICO.
And the main engine continues to operate perfectly. Tank pressures still look nice and stable. And vehicle rates are right down the middle. Approximately 15 seconds of spacecraft separation. Continuing normal spin up. Spacecraft separation.
The flight of AC-201 made launch history. It was the 5th time in 10 years a new version of the Atlas flew straight and true on its maiden voyage, and it was the 50th consecutive successful Atlas launch. This paves the way for the Atlas V EELV. During the flight, the Russian designed and built RD-180 liquid propellant engine performed to expectations, demonstrating its ability to throttle up and down during flight. The single-engine Centaur performed flawlessly, and the spectacular rocket cam video showed in real time the deploying of the extendable nozzle on the single RL-10 engine. The first flight of the Atlas III was a 100% mission success. In addition, the successful flight of Atlas III retired the majority of the risk for the Atlas V EELV program by demonstrating the new RD-180 propulsion system and the single-engine Centaur, the two critical new components of the Atlas V EELV. Congratulations to the entire Atlas team.